Welcome to AH University, brought to you by Aggressive Hydraulics. In this presentation, Ken Range, as Senior Application Engineer at Aggressive Hydraulics, will explore the fundamental operation and key differences between single-acting and double-acting telescopic cylinders.
We're going to talk about the basic operation and the differences between single-acting telescopics, or SATs, and double-acting telescopics, or DATs, as they're so commonly referred to in the industry. We're going to go through a little bit of a refresher as to the forces that create movement in a cylinder. We're going to deal specifically starting with a single-acting telescopic because they're considered somewhat simpler than a double-acting. And then we're going to go into a little bit more in-depth where these different types of tellies are typically used and why, and maybe some of the challenges that are associated with those different types of applications. If you recall, it's the pressurized oil that does the work inside the cylinder. The pressure of that oil on a certain surface area creates a force. The larger the area that pressure is applied to, the higher the force that's created. And because we're talking about telescopics that have different stage sizes, that point about the force created by the area that it's applied to really plays an important role in these telescopic cylinders. We've got to remember that any single-acting cylinder will require an external force to get it to move the opposite direction. Because they typically extend, it would take that external force to cause that single-acting cylinder to retract again. Let's look at the actual cylinders themselves. A telescopic cylinder is called a telly because of the fact that it has multiple nested stages, nesting being a very important term. That nesting of those different pipe components allow you to have a very compact form, but when it extends, have relatively long length to its extended dimensions. On the left, we're going to see a single-acting, single-port telly. And that's important because that port location that you see on the top left of that diagram, that port can be located anywhere on this cylinder. It could be located on the case sidewalls, as long as it's not over the top of the head gland and the bearing that's associated with that head gland at the top of each stage. As long as that port has access to the internal cavity of that telly, that port can be located anywhere, including in the end of the rod. You're going to see a small port identified on the end of the rod. That's a breather, but it could easily be an extension port as well. So that's a nice feature about a single-acting telly, as it gives the customer some plumbing options. To the right, you're going to see a double-acting cylinder, telescopic cylinder. It's got two ports. It is very common for those two ports to be located in the rod of the cylinder so that the cylinder stays stationary, the plumbing stays stationary, but it's the stages that move away from the rod end, or the plunger as we call it. The reason that's so common is because the ports have to be located in a very specific location on a double-acting telescopic cylinder so that when you apply pressure to extend, it fills the appropriate cavity inside the telly to cause it to extend. And the same thing to retract, that retract pressure is applied to an appropriate cavity to cause it to retract. And those limitations are quite strict. The port locations can only vary by a fraction of an inch. And that sometimes causes some difficulty when it comes to actually plumbing these things on a piece of equipment. What you will notice is that there's a significant difference between the seals that are on the pistons of each stage of a telly. A single-acting telly has really only guide rings to cause the stages to stay in place. They're not really a seal. And on a double-acting telly, it's necessary to use cast iron piston rings, or CIPR, because of the fact that if those pistons have to cross a port, in other words, the ports are no longer in the rod end, if those seals have to cross a port, the only seal that will withstand moving across a port is a CIPR type of seal, or cast iron piston ring. If you use any other type of seal, it will have a tendency to expand into that port opening as it crosses. And as it leaves that port opening, it will shear the seal off, cut it off, and your seal is gone. So cast iron piston rings are a necessary evil when it comes to double acting cylinders. But the most important thing to understand about these 2 points is the fact that no telescopic cylinder has got a true positive sealing arrangement. They will all leak some oil from one side of those devices to the other. There will be some drift, and depending on the load that's applied, that can cause significant telescopic cylinder stage movement in the process. And that'll become apparent as we talk about some of the applications in just a few slides. Let's talk about a few more limitations with a telescopic. You're going to see a typical telescopic performance chart listed in that top item number 1. It lists the stages, it lists the size of those stages, and it lists the extend force for each one of those stages. Typically, a telescopic can only work at a maximum of 2,000 psi. There are occasions where we can get up to 3,000 psi, but that's an exception and not a rule. You look at this performance chart, and really the most important thing to pay attention to is the smallest stage or the plunger. It really doesn't matter if the first stage can lift 71,560 pounds, because if that is the load that you're trying to lift, the second, third, and smallest stage aren't strong enough to move it. So what's the benefit of a telescopic cylinder? In actuality, the weight that telescopic cylinder is trying to move has to be capable of the plunger stage, period. Even if the previous stages are more powerful, I'm afraid it's just a fact of the way a telly works. But if the plunger stage can't move the load that you're trying to move, it doesn't really matter. So that bottom line is really critical when it comes to working with a customer and making sure that the cylinder that is being targeted is capable of meeting their performance. In certain cases, and we have done this in the recent past, the load decreases as the cylinder extends. In other words, in a dump body application that's common to telescopic cylinders, as that dump body extends up or the angle increases, the load is dumped and the cylinder decreases. And so we have, with some customers, actually calculated the load loss at various stages in that process to make sure that each stage is capable of doing its work depending on its stroke. That's relatively rare, but that's the only time that the other stages, the first, second, and third stage capability, really is, analyzed to make sure the performance is accurate. It is somewhat rare to do, but it is possible. Having said that, it is really important that a telescopic be loaded for proper operation. If you have a telescopic cylinder that's moving a very light load, there's no guarantee that the stages will move in sequence. We have to consider that a telescopic cylinder is really nothing but multiple cylinders stacked together. You have manufacturing tolerances that you have to account for with each stage. I mean, they're a natural part of machining. One stage can be a little bit tighter than the next. That's just a characteristic of a telescopic. So therefore, if you don't have any load on that telescopic cylinder and you ask it to extend, there's no guarantee that it will extend in sequence from largest stage to smaller stage. It can extend the largest stage, then it could jump to the third stage, then the second stage, then the plunger stage. And that's commonly known as misstaging. So if you have a customer that's asking for a telescopic cylinder and they're asking for it to move a very light load, maybe the telescopic cylinder is positioned horizontally rather than vertically, those can be very risky because we can't guarantee that the cylinder will stage properly. When you look at the fact that there are multiple manufacturers out there that make telescopic cylinders, both single acting and double acting, we have to be aware of the fact that each manufacturer has got their differences or their features. They can use different material sizes for stages. That material size can be metric, it can be imperial or inch or nominal. Just that difference between a metric dimension stage and an imperial or inch dimension stage can be a significant force difference. It might only represent a few millimeters, but when you're talking about a very large stage size for some of the very large telescopics that are out there, that get 10, 12 inches outside diameter, just those few millimeters can result in hundreds of pounds of difference between forces. So it's very risky when you're comparing the performance of different telescopics from different manufacturers, because without having that performance chart or knowledge about the specific stage sizes, the performance can be significant. The other difference is the actual seal types. It is possible to use nothing but tight wear bands on a double-acting telescopic rather than a cast iron piston ring. Those affect the performance of the telescopic itself. And so we have to be careful that if a customer has multiple telescopics working together, maybe to lift a load, they might have 2, 3, or 4 telescopics that they're trying to synchronize. It's important that they should really all be the same type or the same manufacturer's tele, because otherwise you can't guarantee the performance between the different types of teles. So it comes up as a regular question in my interactions with customers. That leads us into step number 5. The simple statement is that if teles are working in a pair, they need to be replaced as a pair. You just can't risk having one tele versus another tele working the same. It's very challenging to do that. Item number 6 is also pretty important. Because of the internal oil flow paths that are inside like a double-acting tele, it's really important that the flow supplied to that telescopic cylinder, specifically the double acting, be greater than 15 GPM. The reason being is that there are large volumes inside the telescopic that must be filled with fluid in order for the telescopic cylinder to respond to the pressure being applied. So if a customer has very low flow, maybe their system isn't set quite right, it'll appear like the telescopic isn't doing anything, that it's stuck. And that's typically related to just, somebody forgot to turn up the flow control valve. At the same time, if they're doing startup and they start at low pressure and they just gradually creep up that flow, it is possible for the oil inside a double-acting telescopic to simply circulate through the fluid routing paths that are internal to the double-acting tele and that are associated with each stage. We'll look at those in just a minute. But it can just simply flow fluid through those oil paths, and yet the cylinder never moves. So if they have greater than 15 GPM, you're pretty much assured that the flow will overcome those small fluid paths and physically act on the stages as we expect them to. And that's a common thing in my experience. I've gone out to numerous application sites where all I've had to do is grab the flow control valve, give it a quarter of a turn, and the cylinder starts working properly. Relative to a single acting tele, it's simply the volume that's inside that single acting tele that has to be filled and continue to fill to move. If the flow is too low, people can see that the single acting tele isn't working, that it's stalled, but in effect it is moving so slow that it's not apparent. So those are a couple of things to keep your eye out for if a customer calls up and complains about issues with their cylinder's performance. Let's talk about the action of a single acting tele in an extend mode. This is a side view of a single acting tele. It's the same view that was used in the previous slide for commonality. You'll see the extend port located at the top left on the case, and that's where pressurized oil is introduced into the tele. In a single acting tele, that pressurized oil fills every void within the tele. There's no area of the cylinder that isn't pressurized with that oil. But you look at this, and as a novice, you might say, well, if everything is pressurized, how the heck does it move? The simple area difference between the side of the piston that's pointing to the left of this diagram and the area of the piston that's pointing to the rod end of this diagram, that area difference on this piston, the blind end of that piston is larger than the rod end of that piston. The larger area sees greater pressure or forces from the oil, and so therefore that stage extends. So the oil that's on the rod side of that piston really doesn't do anything but lubricate the movement of that stage. When this cylinder is fully extended, Remember that that pressurized oil has to be relieved or sent back to tank, and then we need that external force to cause all these stages to return to their retracted state again. So with this type of diagram, it's really, on one hand, it's easy to understand because the entire volume is full of the same oil. On the other hand, it just boils down to a sheer surface area fact that causes the cylinder to move. Once again, the seals that are on the pistons of that single acting tele are not load holding. They're not position holding. So in the case of a dump body like a dump cylinder, it really doesn't matter if that dump body is raised to 60 degrees and maybe it's at 55 degrees or 62 degrees. It really doesn't matter. The load is still going to dump. But if a customer is asking for very specific load positioning, it wouldn't be a good idea to use a single acting tele because it has the most basic seals of either of the telescopic cylinders. Where is a typical single acting telescopic cylinder used? I thought it would be helpful to show some of the industry standard phrases out there for different types of vehicles that these single acting teles are used for. You'll notice that the three types of dump bodies use single acting teles. The types of dump bodies are only important to understand, that various dump bodies have the ability to haul heavier loads. They have lower structure, and so a customer can haul more payload. But that doesn't really impact anything about the telescopic. But if a customer calls up and says, hey, I got a frameless dump body and I'm looking for a tele, just the ability to understand the difference in those types of terms is probably beneficial to the conversation. In addition, we have fork trucks that are shown on the right side of this image. In a basic fork truck, there's a cylinder arrangement with a pulley and a chain that causes the lift forks to raise and lower. In a multi-stage or telescopic fork truck, one that you might see at a port offloading containers or something like that, or lifting pallets onto a very high racking location in some stockroom, the telescopic cylinder moves multiple stages on the frame of the fork truck, causing the forks to raise significant distance. And that distance can be, 2 stories tall. So that telescopic cylinder might have 3, 4, or 5 stages. There are also smaller dump bodies that single acting teles are used for. There is a myriad of different mechanical structures that are used to move those dump bodies. Each has certain mechanical properties that might benefit the mechanism, make it more efficient, or allow you to use a smaller cylinder. But the fact is, the mechanism doesn't really impact the fact that they simply need a telescopic cylinder in most cases to move that dump body. You're going to notice that the bottom, starting with the second row on the right, that one, the next row, and the bottom row are all indicating single acting rod type cylinders. And so it's just important to know that a customer might think he has a tele, but in effect he has a single acting rod cylinder for these types of dump bodies. And it does seem to be a common occurrence when I take phone calls relative to this type of situation. You will notice that on some of these dump body arrangements, you'll notice that the case is positioned case down, rod up, or rod down and case up. That typically is a result of the real estate that's available on the vehicle. If you notice on the left, that trailer is basically a flatbed trailer. The cylinder is mounted to the top of that flatbed, and it's simply extending up that dump body. In that application, they obviously have a significant amount of room to plumb to the larger case diameter that's mounted to the top of the flatbed. That's fine. It doesn't matter to the performance of the telescopic, whether it's case down, or we usually say rod up or rod down. On the right-hand view, it's likely that all the ports are located in the rod end, and that the area behind the cab within the body of the vehicle or the frame of the vehicle is so tight that they only have room for that smaller plunger diameter and the plumbing associated with it. But neither application has any impact on the operation of the cylinder. All the rules apply, and so it doesn't really matter. Let's move on to double acting cylinders and do a comparison to their performance. In a double acting cylinder, with the ports in the rod, it's very important that the two fluid locations within the cylinder be segregated and separated cleanly. So the orange area in the center of this diagram represents oil flow to the blind end of each piston. It just flows into that large cavity that's at the opposite the rod end. The yellow area represents the fluid flow to the rod side of each piston, and that's accomplished through these oil passage ports that you see in each stage. They're not ideally located in this diagram, but the concept still holds true. Oil from the yellow cylinder fills all these cavities that are located on the rod side of each piston. So you have a means of controlling the direction that each piston flows by applying pressurized force to one side of the piston or the other side of the piston. So to extend this type of double-acting cylinder, the extend port is pressurized. That extend force acts on only the rod or the blind end of each piston, and it causes each stage to extend. Meanwhile, the oil on the rod side of those pistons is expelled through the retract port at low pressure, sent to tank, and relatively straightforward in its operation. Another example of how that fluid is pressurized, it was just a better diagram that I could find for an actual extended cylinder. And all it does is represent how the pressurized oil, in this case the blue oil, causes those pistons to move toward the rod end of the case. If we are retracting that, the pressure is reversed. The red pressure goes to the rod side of the pistons, and that pressure causes those pistons to move the other direction or retract the cylinder. But it's clear in these types of diagrams how the seals actually separate the two pressure chambers of each cylinder. Double-acting cylinder applications, because you have control of both the extend movement and the retract movement, you're not depending on an external force to cause the cylinder to retract. So therefore, these cylinders can be positioned vertically, horizontally, rod up, rod down. It really doesn't matter. As long as there's a load to control the staging, these cylinders are very flexible. They're common in garbage trucks for compactors or various movement of some of the features on a garbage truck. They're common in waste packers or balers, as they're also often known, trash compactors, transfer trucks that are moving large loads between vehicles, the roll-offs that you see on the bottom left picture, and in construction equipment that's represented by the concrete pumper in the right-hand view. Like a concrete pumper or a garbage truck, they need to be very compact to move across the roads in the country, but when they go into work mode, they can extend to very large sizes. So it's very beneficial to have double-acting cylinders in these cases. When it comes to a customer that might need a custom telescopic cylinder, they can be made custom. Some of the terminology that you might hear used that can cause confusion is jump a sleeve or jump a stage. That basically means that a customer is asking for the plunger to be a certain size and have a certain performance, but the other stages can be of a different size where they're not truly nested as close as some of the diagrams previously showed. In other words, there will be a large separation between one stage and the next. So jump a stage or jump a sleeve is a term that's commonly referred to in discussions with customers, and in comparing performance of one manufacturer's telescopic to another telescopic, you will often find that there's been a jump a sleeve type of arrangement in the competitor cylinders because they are so customized. And it's possible to do so. It takes a little bit of work, takes some engineering time, but it's definitely not a thing that's impossible. A double-wall telescopic cylinder is another feature where an extra piece of pipe is included internal to the telescopic cylinder's design that allows you to use position-holding seal arrangements because there's a set surface that piston then runs against, and you can actually create a double-acting tele that's double wall that's truly position holding like a normal rod type cylinder. In this case, you can't go past about 2 or 3 stages, otherwise the cylinder just gets too large. But if position holding is really important for a telescopic, double wall is definitely an option to go to. It's also possible to build a telescopic that has stages that are double acting and stages that are single acting, all within one cylinder case. We talked about those oil flow paths and how it controls the location of the pressurized oil. It's just a hybrid between the oil flow paths of a single acting cylinder and the oil flow paths of a double acting cylinder. It's done on a regular basis, and it's an option. It's not common, but it is done on a regular basis. So it's also possible for us to include control valves in the ports of a single acting and double acting tele. Wherever those ports are located, we can position valves. It's common to position them within the valves or the ports just to save real estate. So in the case of like a double acting tele, there are commonly control valves that are positioned in the plunger where the extend and retract lines are connected. We can add position sensing devices to telescopics. It's not an ideal application, but if it's a must-have, there are string potentiometers that are attached to the smallest stage inside the tele. And as those stages move, because the plunger is shifted out with every tele as it extends, the string potentiometer can give you position location. That's been done a few times, although teles have a common operating pressure of 2,000 psi. 3,000 psi is somewhat rarer, and higher pressure cylinders teles are even more rare because it becomes more difficult to find seals that'll work in a telescopic environment or design and at higher pressures. Special plating options. Typically, the ID of the stages of a telescopic cylinder are chromed because it makes a very nice wear surface that the seals can ride upon. For corrosion protection, the OD of the plunger and the stages can be chromed as well. So as they extend and they're subjected to environmental situations, they have the same wear property as a normal chromed rod. But at the same time, nitriding, nickel plating, various other types of plating options are available for environments that have high corrosion, maybe in an agricultural situation where they're moving manure. Manure has a very high acid content, and there's platings that can be applied there. At the same time, the mixture of juices that's created in a garbage truck situation can be very corrosive, or in just an industrial type situation where they're using chemicals that are very oxidizing or very corrosive. We have some plating options for those stages. The last option for teles is, of course, mounting. True of any cylinder, cross tubes, flanges, spherical bearings, all these options apply to a telescopic cylinder as well. So there can be a long list of things that we need to get clarified when a customer is asking for a tele, just to make sure that we have all the applicable features captured. Let's talk about some issues that can be experienced with teles. We already covered bullet number 1 with the low gallon per minute. Should be greater than 15 GPM or it'll stall. Another common situation with a telescopic cylinder is that there's air trapped during installation. And the most novice way to recognize this is the fact that it's the oil that's inside a telescopic that moves the stages. If there's air in there, the air compresses and it doesn't move the stages. So most telescopic cylinders will include an air breathe valve on the end of the cylinder that's the highest or mounted up. And during installation, you fill the cylinder with oil. You open the air bleed valve until you get a little burp of oil out, saying that all the air has been expelled. You tighten down the air bleed valve, and that's the only time it's used. Maybe on a regular basis, that air is burped off, let's say once a year or once a season. But we commonly get calls for teles that don't work because it's been changed and there's air introduced into the lines that collects within the telescopic and the telescopic stops moving. So it's a common thing. Misstaging we talked about, and we've got to remember that these are wear components. Over the life of a cylinder, they break in, they wear. So therefore, misstaging of a new cylinder can be caused by manufacturing tolerances. In other words, one stage is very tight, one stage is very loose, and they can misstage then appropriately. After cycling that cylinder a number of times, it's likely that they will stage properly, but it could take a number of cycles before that's true. We also have to consider worn or old cylinders where the guiding structures inside the cylinder are worn. That can cause binding, and therefore the cylinder misstages. In a number of situations, it might just be applicable to reseal that telescopic cylinder on all the stages, but in some cases it's necessary to fabricate replacement components for various stages to get the proper staging back. The stage ballooning. This is a little bit of an interesting situation. We talked about how pressure applied to area creates force. And the larger the area that pressure is applied to, the greater the force that's created. Imagine a double-acting cylinder that's fully extended, and you want to cause that cylinder to retract. And let's say in this instance, there's an external force associated with retracting that cylinder, some kind of a weight of a dump body or a load or whatever it might be. When either a single-acting tele or a double-acting tele is retracted, the oil that's on the blind end of the piston on that side of the case must absolutely have a clear path back to tank without restriction. If you imagine it, you're pushing on the small side of those pistons to cause it to retract. The large side of the piston, which is a larger area, if that oil isn't allowed to leave, that large area of the piston is building pressure against that oil that might be low pressure, but it still has pressure. The force that's created by the blind end of that piston can be so great that it can cause the case of the cylinder to expand or balloon. It's a common thing to see when a plumbing issue exists that doesn't allow free flow of that oil back to tank. But stage ballooning at any stage, it doesn't have to just be the case. It can be the large diameter of any of the stages can cause ballooning. And guess what? That cylinder doesn't move after that happens. If the case balloons, you no longer have a seal with the first stage. If a stage balloon, it's going to stick in the head gland of the other stage. So it can be a real mess when that actually happens. But stage ballooning is not uncommon. Happens all the time. Side loading. This is a term that's commonly used by customers that have an issue with their installation. If they have equipment that isn't square or straight, they will often ask for a cylinder that can handle side loading. There is no cylinder that can withstand side loading. The reason being is we have a simple lever arm situation. At the bottom, you'll notice that there's a two-stage telescopic represented by these graphics. If that cylinder is fully extended and you apply a load to the end of the rod, you take that load times the length of the stages, and that results in a force at this piston side, at this piston that's inside the case. Those forces can be hundreds and hundreds and hundreds of pounds when there's only a load applied that's a pound or two because of the multiplication factor of the lever arm. And so side loading can lock up any type of cylinder, whether it be single acting, double acting, rod type, or whatever type. We always have to be sure that there's never a side loading situation with an installation because a cylinder isn't capable of fixing that, geometrical misalignment. I've tried to take some time to explain what the differences are between single acting teles and double acting. Their use can be varied as represented by the pictures shown on the screen, from dump bodies to observatories to rail equipment, mining, drilling, plumbing, or oil patch, et cetera, et cetera. So there's quite a market out there for these types of devices. And with some of these points, I hope it makes it easier for you to communicate with your customers and pick the right product for them. And thanks for your time.
Contact us today to start your purpose-built process.